Chapter 1, Lesson 3, Solving Equations. This is going to be fun. Let's go. So we are solving equations. This is what it's all about, so we can solve stuff, right? Okay, so our basic steps to follow, right there. So we've got distribute, and follow all of our properties that we've already been over. Simplify each side of the equation, combine like terms, follow the associative property and all that good stuff. Move variables, similar variables to one side. So you can either move all the variables to the left or to the right, doesn't matter. Usually you want your variables all on one side and then maybe a number on the other side, and then you can solve from there. And that's where we use that inverse operations. So let's see what that looks like. So here I am on number 1. It says 6n plus 5 equals 2. So step 1, we're going to distribute. So that 6 goes into the n and the 5. So we get 6n plus 6 times 5 is 30 equals 2. Okay, so now we simplify each side. That side is simplified, that side is simplified, done. Move variables to one side, so I'm going to move all of my n's to the left, and all of my numbers to the right. So here we go. So the n is already on the left side of my equal sign, so we're going to leave it there. So then that 30 needs to go over to the other side. So we are going to subtract 30 from both sides of the equation. You can do anything you want to an equation as long as you do it to both sides of the equal sign. So that cancels out. 2 minus 30 is negative 28. So we have 6n equals negative 28. So we're going to divide both sides by 6 because we want that n by itself. So then we're going to have n equals a number, which is our answer, right? So our answer is this, but we need to simplify that. That's not good enough. We can do better than that. So that's going to equal, they're both even, so you can pull 2 out. That's going to be negative 1, 4 over 3, and that's going to be our answer. So n equals negative 14 over 3. Not terrible, right? Let's try another one. All right, so here we are on number 2. Looks like we've got some distributing to do. So remember, our first step is to distribute. So that means we've got 15 minus, 9x all over negative 4 equals negative 15. Okay, simplify each side. Done. Move variables to one side. So I'm probably just going to leave them on the leave the x on the left side. Doesn't matter if you want to move to the left or the right, whatever. But this negative 4, that's kind of in the way. So again, we're going to use the identity property, but we're going to do whatever we do to both sides of the equation. So if I multiply this side by a negative 4, that's going to cancel these out and turn that into a 1. I also have to multiply this side by a negative 4. So I just multiplied both sides of the equation by a negative 4. So then we got 15 minus 9x equals negative 15 times negative 4, which is positive 60. I used a calculator for that one. You guys can do it in your head. Great. Can't. That's fine too. So we are still trying to isolate this x by itself. So we're going to minus 15 to both sides. So we got negative 9x equals 45. Sure. I'll take it. So then we still need to get this x by itself. So then we're going to divide both sides by negative 9 to get rid of that 9. So then we're going to have x equals 45 divided by negative 9 is what? Negative 5. Equation solved. So for number 3, again, we've got some distribution to do. That 2's going a couple places. Let's get into it. So 2 times 2 is 4. 2 times negative 7 is minus 14y. Minus 5 equals 1100. What? No, 111. Words mean things. So simplify both sides. We've got a 4, negative 5. So we'll just do negative 14y minus 1 equals 1101. No, 111. So we're going to leave the y's on the left, put everything else on the right. We're going to add 1 to both sides. Now we've got negative 14y equals 112. Now we're going to divide both sides by negative 14. I certainly don't know that off the top of my head. So I'm going to shove that into my calculator. And my calculator tells me y is equal to negative 8. Boop. Okay, so number 4 looks a little bit more interesting. We got some fractions. Fractions are always fun, for lack of a better word. But it's not terrible. Just keep it, take it step by step, and the process is still the same. So first, I want to distribute. Yeah, let's do that. So we're going to distribute that there and then there. And this is where we're going to see if you remember how to multiply fractions or not. So if we take this first one, negative 15 over 16 times 4 over 5. Remember, this will cancel out with that. That turns into a 3. This will cancel out with that. This turns into what? 4. So now we just have negative 3/4. So over here, negative 16 equals negative 3/4 q plus, so then when we take this guy here, we've got negative 15 over 16 times 32 over 3. That can be reduced, so we got 5 and 1 down here. 16 and 32, that's 2, right? 2 times 16, yeah, 2 times 16 is 32. That'll go down to 1. So what we have left over is we've got a 5, 2, and these are all 1s, so whatever. So if we just multiply across, 5 times 2 is 10, we got negative 10. So that means that we got negative 10 right there. Okay, so let's move. We'll move all the numbers to the left and leave the q on the right, just for funsies. So we're going to add 10 to both sides to get rid of that guy. So then we've got negative 6 equals negative 3 over 4 times q. So now to turn this into 1, we're going to multiply by what's called the reciprocal. So we've been doing that, but I haven't used the word reciprocal yet. Here's what it is. The reciprocal is just the opposite of that. So 3 over 4, we're going to multiply both sides by 4 over 3. And we'll just make it negative to do 2 steps in one time. So we'll multiply this side by negative 4 over 3. So this is like negative 6 over 1. So again, 3, that goes down to 1. This goes down to 2. So negative 4 times negative 4 times negative 2 is positive 8 equals Q. That is satisfying. I love it when they all just cancel out. It's great. Okay, you try the rest of these examples, and we'll see how you do. I'm going to skip ahead to... So I wanted to go over some of these special cases. They'll happen occasionally, just to keep an eye out. So we're going to try number 11 here. So follow the same process we've been doing. We'll distribute this 5. So then we've got 1 plus 3c equals 5 minus 5c plus 8c. Oh, let's, I don't know, throw all the c's to the right and all the numbers to the left? Sure, why not? So minus 3c minus 3. Oh, no, we need to simplify first. That was my bad. Whoops. Getting ahead of myself here. Okay, so we can simplify here. 1 plus 3c equals 5 plus 5, 6, 7, 8, 3c. I like using my fingers. Get over it. Okay, so now we can, there's 3c on both sides. So if you move the c's to one side, you're going to have minus 3c, minus 3c. Those both go to 0. So now we have 1 equals 5. That is not true. 1 does not equal 5. So if you find something, if you have an equation that ends in 1 equals 5, your answer is no solution. That means that this equation up here is not true. It is false. It cannot happen. If you're building a bridge, your bridge fell down. If you're building a building, it collapsed. It cannot work. Whatever you are working with, there is no solution to make that work. So number 12 shows us our next special case. Let's go ahead and solve it and see what happens. So we're going to distribute first. So our negative 8 is going to go into x. So on the right side of this equation, we have negative 8x. Negative times a negative is a positive. 8 times 5 is 40. So then we have negative 8x over here and 40. So you can see they're kind of the same on both sides, but we'll just kind of see it through. So if we add 8x to both sides, that cancels that out, and we have 40 equals 40. Or if you were to cancel out the 40s, you would have something like negative 8x equals negative 8x, which could simplify to x equals x. These are all true statements, but they're not helpful. So what that means is that our solution is all numbers. I can plug any number in for that x, and it's going to equal itself. So your answer would be all real numbers, or you can write up all real numbers. Either one works. So we have a case for no solution over here. We have a case for all solutions over there. They'll come up from time to time. It's good to keep track of them. So 13 and 14 are proportions. It's just a fraction equals to a fraction. Go through the same process. So to move this 3 over to the other side, you're going to multiply both sides by 3. And the same thing with x plus 4. You're just going to multiply this whole thing by x plus 4, and then this whole side by x plus 4. So we can go ahead and do that one real quick. So So what that looks like is, multiply both sides by 3, multiply both sides by x plus 4. So we've got 5 times x plus 4 equals 3 times 2. 3 times 2, shoot. And then we'll simplify that. That's the easy one. 5 times x, 5x plus 20. So we'll move all the numbers over to the right. So we've got 5x equals, we're going to subtract 20 from both sides. And so then that's going to be what? 14 negative 14. So then your x is going to be equal to negative 14 over 5. So again, it's the same process technically, but it kind of looks weird because it's a proportion. You may have learned this as cross multiplying. You know, when you multiply across like that, that's where they're getting it from. You're just using the properties for a specific case called proportions. Okay, you tried the other proportion by yourself. That's actually number 12. Number 14. So we're going to go on to, I wanted to show you how the literal equations kind of work. So the directions say solve each equation or formula for the specific variable. So it's telling you which variable it wants you to solve for, and then you have to play the algebra game to get that variable equals everything else. So you'll see this over and over again, solve for x, solve for y, solve for z, solve for the circumference, solve for whatever. In this case, they are telling you what to solve for. So number 15 says solve for pi. Okay, that's kind of weird. We know what pi equals, but it is a useful thing if you're looking for a different variable and you know what pi equals, so you want to get everything to equal a number. Anyway, it says solve for pi, so let's solve for pi. Pi is located right there. We are going to move the 2 and the r to the other side of the equation. So we're going to divide both sides by 2r. That's a 5, not an r. And then that's where we're kind of done. So c over 2r equals pi. Ta-da! Okay, number 16 is a little more interesting in my opinion. So it says solve for p. This is useful if you've got a computer program or something and you want an equation that has specific variables, but either way, so we've got p over here. We want to get this a and this 1/2 to the other side. So we're going to divide both sides by little a. Okay, so what that's going to look like is we've got capital A, lowercase a, equals 1/2 p. So then in order to get that 1/2 to the other side, we're going to multiply both sides by 2. So then our final answer is 2 capital A over little a equals p. Welcome to physics. Just for fun, we're going to do one more, and I'll let you try the other 3. Again, this is just getting you used to being able to solve for a variable, even though there are other variables, other letters on the other side of the equation. That's fine. So this one says solve for b. Got it. So now b is stuck in this fraction. So first we got to get it out of the fraction. So in order to do that, we're going to multiply both sides by c. And then the c's will cancel out, identity property. So then we have a plus b equals 5c. Okay, so now we're solving for b, so we want b by itself. We're going to subtract both sides by a. So then we're going to have b equals 5c minus a. There's your answer. All right, try the other 3 by yourself, and we'll see how you do.